Good evening, everybody. Thank you so much for your time. Tonight we're going to talk about edge analytics. So this is something that in the IoT space is, I think, probably very relevant. And the reason why is because you have sensors that essentially create, for lack of a better description, a lot of noise, right? So sensors can call back their own data, once every few seconds, or it can be extremely noisy and do 100 times a second or more, right? And obviously there's reasons for those sensors to read that much data, but what I'm going to be talking about tonight is a way that you can harness that data without being a data hog and be able to do something or take action on it. Because everybody knows that really when you're listening and looking at data, if you miss something, you could potentially miss a pointer in the pattern. You could miss something that's very important. And so really the rule is you have to get everything so you can find the something that you're most interested in. So analytics at the edge gives you kind of this ability to push out some intelligence and smarts to not only capture this information and do something with it, but also give you a bit more flexibility to scale, grow, and to really quicker time to market. Because this platform that is currently incubating with Apache from IBM, it's an open source project that we've delivered early this year. We've taken some things that we thought were pretty important to doing analytics at the edge and put them out there in a very, very lightweight footprint. So tonight, this is what I'm going to be talking about. And essentially, I want to get into kind of the why, and I'll show you a demonstration that we have. It's based on kind of a water conservation use case, but I think it's fairly applicable that you might be able to apply it to something, hopefully, that you guys have already thought about. So let's define the edge. This is something that is really where the sensor is local. You'll oftentimes have limited bandwidth. You really need access to the edge for the system that's doing the analytics, right? So none of this sensor data will do you any good unless you put some analysis around it, so there has to be connectivity. At a lot of times, the edge is a constrained type area where you don't have a lot of compute power, you don't have a lot of ability to do anything fancy. Here's something that's more profound. Millions of devices, right? You've got a ton of things out there that are reading anything from multiple types of readings to specific sensors for, you could have hundreds and hundreds of sensors on a particular machine, and you have a factory or some sort of operation in the field that has 50, 100 of those machines. So then now you're talking exponentially more data, more things to track, more things to deal with. So here's some other examples of vehicles. I heard you guys talk about your connected car. Vehicles are absolutely an edge type space. Buildings, warehouses, even smartphones, industrial machines. You name it. There's anywhere you have a sensor that is gathering data that is not in a data center that's connected to a high throughput type bus, right? So that's really kind of the edge. And the Pi is a good example of some great edge type devices that you can do sandbox type stuff, proof of concepts. And so these edge spaces are somewhat numerous. So I mentioned this before, but what's the value of the edge? The reduce of the communication costs, that reduction in cost. I mean, if you're an oil, servicing company and you have to track things that are so far off the grid that all you can do is communicate via satellite, guess what? That's expensive, right? You know, the value of doing things is at the edge is really, you know, what about reacting locally, right? Not having to wait for the latency of the data to transfer, something to, you know, some process to be run in the cloud or in a data center, and then somebody to pick up a, you know, some sort of work in the, you know, job in the queue and call somebody. I mean, there'd be a lot of lapse time there. So be able to react locally to events, that, especially where you have potential catastrophic failure, right? Or what might make more sense is potential lost revenue, right? So you have, I mentioned the smartphone a second ago, being able to capture revenue where you haven't been able to do that before. Not to mention the fact of, you know, at the edge, they're not all the same, right? All the devices and all the sensors, you've got a myriad of manufacturers, a myriad of standards out there. So, you know, doing analytics at the edge really helps kind of shore up some of these challenges. Introduce Apache Edgent. Now, Apache Edgent is an open source offering from IBM. I just mentioned that, but I mentioned it again because in light of what IBM has done with our go-to-market, we have really committed to the open source market. We've put a tremendous amount of money into resources behind and intelligence behind open source products. Spark is something that we have really fully, as a company, gotten behind. We have innovation centers, we have people. We are by far, more than the next 3 companies combined, the largest contributor to Spark 2.0 than anybody else. We are committed to open source. So why Edgent? Well, we have had, IBM has had a streaming analytics offering since 2008, 2009. And what we've done is, when we went GA with that, we had a fairly mature product because that product or that offering had sort of grown up in a space that was isolated but with incredible demands. So, you know, I'll say, you know, from a government perspective, that was who helped kind of mature that type of technology. So, any type of digital data or digital type source, and you need to do something with it, immediately get from the noise to the signal, have context, all of that. So our streaming analytics offering is a licensed software that IBM sells for on-prem. We also have it in the cloud, hybrid cloud. It runs anywhere. It is something that we have a lot of competitive difference with in the market. What we did is we took some things out of that offering and open sourced them. We thought that if we took something that was very robust and mature to begin with and said, let's take this and open source it, we'd have sort of a, you know, an advanced, a better mover advantage on this type of offering in the open source community. So it's an extensible SDK, heavy analytics, very modular. It runs on Raspberry Pi. It runs on Android. And that's not to say that that's all it'll run on, because this is something that's new this year. I'm talking to you about this because we want you to help us guide where it needs to go. What do you care about? What do you not care about? What are the platforms that you're dealing with in your job that you have to say, I need Edgent to do this on this machine, and this machine runs this type of, you know, operating system or whatever. We want that to be an interactive thing. All we need is Java 8, Java 7, and so, you know, it's very lightweight. So some of the features, and this is really what makes, in my opinion, you know, a lot of the difference between other offerings and Edgent. So we have map, you know, state. We can keep state very easily. We can also filter, aggregate, split, union, join, and do a deadman filter. A lot of the sensors, like if you, especially if you have certain things on a regular time series that are coming in, and it's sometimes they're out of, out of what a normal range, we can filter those out, right? And then you can get data that actually is meaningful beyond Edgent. Connectivity, we can do Kafka, we can do MQTT. This is all out of the box. So all you have to do is plug into these existing connectors. What does that mean? All of the stuff that I just mentioned is something that you don't have to develop from scratch. This is logic that is in modules that come with the product, and you can leverage them right away. So in addition to MQTT, we support HTTP WebSockets, JDBC, file, also of course. Microkernel structure, as I mentioned, very lightweight. We have a development console that you can use to see kind of the data flowing. Once you've developed your topology application, you can see kind of the data flowing to, which is, I think, interesting. The visual aid allows you to, as a developer, find bottlenecks, find potential things that, maybe your nodes that are, or maybe functions that are not performing well, that maybe have lower throughput than the other stuff. So maybe you can rewrite that code a little bit more efficiently before you put it into further testing and production. Visibility is something, and then of course we have JUnit integration for testing. So what we have is, really this is a streaming analytics paradigm. So it's, everything is a stream. And of course streaming analytics is such an overloaded term nowadays. Everybody says real time, everybody says streaming, and really what you have to define is what does streaming mean to them, right? So for us, everything is an infinite sequence. There's no barriers. You don't have like micro batching. It's not, there's not a start and stop. It's just all continuous. So that's what Edgent allows for. Everything, a tuple, is a record or an event in flight. You can do very easy data manipulation and communication to the back end. Windowing based on time or counts. A lot of times that's extremely helpful when you want to do some sort of aggregate or run some sort of analytic. Water conservation. So this is the demonstration I'm going to show you, and let me just talk a little bit about what it is. So this demonstration was built by our product group, and what the developers thought was, how many times have you been driving and you have it's raining and you drive by a building and their sprinklers are on? You seen that? Yep. In this state, as well as California, that hits us especially hard because, just a few years ago we were in a horrible drought, right? And so water conservation is something that a lot of people don't pay attention to. We're under restrictions. I know any homeowners in here having to do with the local municipality and their rules about you can do it between these hours and that hours. What if you could automate that system in such a way that you could, based off the moisture in the ground, drive whether or not you need to water your grass? Let me add this to it. What if you could have an integration to a central cloud system that had the ability to deploy rules, whether or not you have a ban during these hours in place or not, whether or not the weather says it's going to rain today or not, based on a certain percentage as well. That's what this application demonstration does. So I'm gonna, that essentially what it's it, but what it does is illustrate through a Raspberry Pi, which is something I have here, connected to a 7-inch display, but I have a Raspberry Pi connected to a moisture sensor, and the Pi is running analytics on the moisture, and it's reporting that data to the cloud, where I have a streaming analytics application running. And what that streaming analytics application is doing is it's taking that input and saying, okay, what's your moisture sensor? What's the threshold there? Okay, what's the weather look like? Do we have a water ban in place? And if this thing says, I want to turn the sprinklers on, the streaming analytics engine says, well, the rules say you can't, so you're not. Or the rules say you can, so let's go ahead and fire them up. So that's something that allows you to do edge analytics as well as integrate with, cloud-based.
Let's say it rained 2 days ago and you got a little bit of moisture, right?
Mm-hmm.
You want to water, but you don't have, you just want a little bit of water, not a lot of water. You think you could?
Well, that would be driven by the moisture sensor.
Right.
So you have a threshold, a calibration that sensor would say, I'm looking for so much percentage of moisture.
So the moisture sensor will detect when it turns off, not a time-based.
Right. It's not time-based. That's the beauty of this thing.
Yeah.
That's where the edge analytics comes from, because you're doing it locally. You care about what's in your yard. You don't really care about, a general timeline. So these are the components. This is how it essentially works. So we have Edgent on a Pi, talking to our cloud through the Internet of Things protocol, which is essentially an IBM wrapped MQTT type communication. But it's specific with security for our own platform as a service. So that's why we use it. Yes, sir.
So could we be running other things on this Pi simultaneously?
Absolutely. Yeah. It's a fairly lightweight application. It doesn't require, looking at the CPU, you won't see it pegged at all. So, yeah.
Good question.
So
he does have an airplane to catch, right?
So streaming analytics in the platform, in the cloud, integrating with weather data for that locality, and then feeding a dashboard. That's essentially what you're going to see. So all of this flows very nicely, and let me toggle into the demonstration here. So here's my dashboard. Oops, there it is. Okay. So here we have what's happening here. Let me just explain this for a second before I start messing around with the moisture sensor. So this curve signifies, this is time, and over there is moisture percentage. So this curve signifies ground moisture, and see how it's going down? This is a green dot right here signifying we've crossed the threshold of acceptable lack of moisture. Can I get a sprinkler go? It says yes, turns on the sprinkler, runs the sprinkler, and then here's what I was talking about, the threshold of moisture for the sprinkler to turn off, not time-based, and then it repeats. So now, watch what happens. So I have this little moisture sensor. All I'm going to do is this. Watch what happens. That curve comes right back up.
Turns off.
Let me turn this off. And then go back in. I affect the curve that way. It goes straight, see? Pull it out. Now, notice, I'll do that again, but notice below here is a little sign, or a little alert that basically says yes or no, you can turn on the sprinkler. So, what I also want to point out is, again, this is just a demonstration, but up here is the weather. I can actually tweak the weather for where I'm looking. I can also turn the water ban, the governmental regulations, on or off. So either way you look at it, we're reacting locally, but we're not having to use anything, any smarts necessarily. The edge component, if you will, is helping drive the value. So the smarts are in the Pi. All the streaming analytics is doing is more common-based things. Like everybody's got governmental relations, governmental regulations, right? So that's a common thing. So is weather, right? So the purpose of the streaming analytics really is to illustrate the integration, central integration for a number of sensors. Yes?
I was going to ask if the edge point is powerful enough to extrapolate. If you lose connectivity to sources that tell you that, say, the weather information, can it extrapolate and kind of predict what's going to happen?
So in this case, it has to get, the edge device has to get its okay to turn on the sprinkler from the streaming analytics engine. So if it loses connectivity, it doesn't turn on.
So the go, no-go is not on the Pi?
It's not.
But you could move it there?
You could move it there.
Nice.
Something else that's interesting is we just came out with we've shipped a couple of versions of Edgent this year, since we announced it earlier this year, and we now have the ability to push down models, analytic models into Edgent, something like an SPSS model, like a predictive model. There's not any framework that I know of that runs at the edge that allows you to do that type of analytics. So this is a huge difference maker for Edgent. Something else is our streaming analytics platform has now visibility and control over edge devices that are running Edgent. So
Is that something you can run on Bluemix? Or
yes,
in the IBM
yes.
cloud?
Matter of fact, this is Bluemix.
Oh, nice.
Yes. So this is essentially the demo. And again, what we're doing here is we have central operations that are common, but then we have local operations that are specific to this particular logic here. Yes.
So your prediction would only be based upon the local knowledge?
Yes. Yes.
But
Because your model's running here, not there.
Nice.
Yes.
Could you talk a little bit about the security that you mentioned earlier?
Sure. So from a secure perspective, the data that's coming across the wire is coming over an IOTF protocol, which is, like I said, IBM's wrapped that MQTT protocol to communicate specifically with Bluemix. And that IOTF protocol embeds some things with it where you have an authorization key that is recognized here that you can talk to, so you're not having just arbitrary devices, feed data into this. There are offerings from partners that actually secure and encrypt that over the network if that's something that you need to do. Edgent doesn't do that because Edgent focuses on doing the analytics locally. The communications between the two is somewhat of up to you how you want to architect it, but there are offerings out there that will make sure everything's encrypted, so if you have sensitive private data
And that's on Bluemix?
That's not through Bluemix, that's actually through a partner. Yes, sir.
How is your Pi and the sensor connected? Is it through
The
Bluetooth or?
GPIO,
It's
just
a-
a,
Oh, it's
hardware.
physically connected?
Yes.
Okay.
yeah,
Okay.
just wire.
But there's some great Bluetooth sensors out there too.
Yeah.
Sure, wireless can, absolutely, yes.
You mentioned Bluemix. I'm sorry, I'm not familiar with it. Can you mention
Sure,
what
so
that is?
Bluemix essentially is IBM's platform as a service, and all of our whole portfolio plus additional third-party products and offerings can be available and consumable from Bluemix. We call it Bluemix because it's just a mixture of anything from analytic type tools to data storage to modeling, as well as data exploration and wrangling. I mean, there's a ton of stuff out there to do visualizations, it's a complete portfolio. And what's even more important about Bluemix, it's really kind of our garage type, sandbox type use case. Although there are customers that are using it as their production system, but when you look at the costs and time to deploy and stand up an environment, and maybe at your organization, maybe you're looking at weeks. You can have something running up in minutes on this. I mean, it's fast. So say you want a streaming analytics cluster with some Spark and SPSS services and a time series database repository. In about 15 minutes, you can have all of that running.
Thanks.
Certainly. And IBM has just announced kind of our data science experience, which really is kind of how we want to go to market with that type of platform, so that everybody kind of has a unified way to deal with data, to do analytics, to find kind of the signal from the noise, and then also get data in there, as well as leave data on-prem to do sort of deep research and modeling. But back to Edge Analytics. This is something that you can certainly see there. There's the ability to stand up an application with windowing, aggregations, standard deviation, mean, max, min, all of that, and then do filtering. You can do that in a very short time, because you're not building any of that stuff from scratch. All you're doing is kind of wiring it up, so to speak. So Edgent's like I said, it's based on Java, so anybody who's familiar with Java, you can get started right away. Any other questions about the demonstration?
I have a
Yes, sir.
question. Could it do, does the system do like establish a baseline and detect abnormal behavior?
So anomaly detection is something that we have in streaming analytics, but not yet in Edgent. But that is something that I'm sure we'll have potentially on the roadmap. So anomaly detection is something that requires state, and it already does that to some extent, right? We can do some level of state to ensure that you have data to enrich, or data to understand what's something you care about, what's something you don't care about. But the state for anomaly detection is a little bit different, and the function algorithm is a little bit different. But from that perspective, it's something that you could build very easily. But I'm sure that it should be part of the product soon. Yes. Go ahead.
So what's the IBM goal here? Is it to you providing a core base of functionality, and then us as a consumer, we can come in and say, well, can you add this function or customize that for us? Or?
Great question. Edgent is a community. We're looking to build this community out of people like you who do this on a day-to-day basis, who have to solve problems in the IoT space on a day-to-day basis. And so when you get and become part of the community, you can suggest changes, suggest enhancements, and that's something that we definitely will listen to, because we want to grow this and make it stronger, so that it's more relevant. Definitely. Sure.
I'm curious about the scenario where I can have a stream going into your edge device doing some pattern recognition, then convert the data and put it out locally as well, and also send some data upstream to your cloud infrastructure.
Sure. There's a use case that we had. We built a demo that was a coin drop demo, which processed coin sounds. And so what that was we had Edgent handling the sound processing and filtering, and then sent the relevant information to the streaming analytics service in the cloud.
But you could send it out locally as well, just another.
Sure, you can egress. You don't have to send it to the cloud. You can egress anywhere you want. It doesn't have to. Exactly. That's the whole point of this, is that you don't have to go and over data lines to
Build a file
more expensive
system or
stuff.
whatever, an
Yeah.
API. Nice.
Yeah. Yes, sir.
Are you aware of any specific projects at this time that the group we could somehow get involved with?
So currently we don't have anything that that I could at this point, but I really could not stress enough to sort of, I'm going to leave you the links to the Edgent site. Please sign up, get involved, start making comments. We want to know, what you care about, what you don't care about. Download the product. There's at least 24 sample applications that are already built and ready to go. All you have to do is connect up your sensor and wire up, choose whatever point you want to egress to and run the script, and it's off and running. You don't have to build the application. We just want to get you guys, get your hands on the, on the software and get some feedback to figure out, what's relevant, what's not, because we think we're onto something here from our approach and our go-to-market. Yes?
Do you think IBM might be interested in collaborating with our group somehow if we ever came up with an idea or something?
There's absolutely no reason why we couldn't do a POC together or some sort of proof of technology, or even better, work together to compete in a hackathon to build something, right? To make that something relevant to not only yourselves but us, and we can work together to make that happen.
Yeah, I'd like to extend an open invitation for that on behalf of the group.
Okay. Yes, sir.
Well, just talk about this particular example. Let's say the sensors have a tendency to become bad or less sensitive. How does the Edgent have any kind of intelligence to accommodate to this kind of a change? Like, take one extreme example. Let's say the sensor gone bad. It's thinking it's dry all the time, and the sprinkler working all the time. You don't have a waste tons of water.
That's a good point. And so while that, I think that's something that you could easily bring into your Edgent application. There's nothing that I'm thinking of right now that would be a sample to show you kind of that type of logic. But really, what that is more of a I've heard it spoken about where you have sort of that type of logic in the cloud, so that you're trying to detect failure of a specific sensor. If it's reporting, erroneous data, or, to determine the context of that erroneous data, and then to flag it as erroneous, and then, alert somebody to check it, that absolutely can be done. It's and it's something that is pretty prevalent with streaming analytics, but not yet. That logic's not yet in Edgent.
Okay, thanks.
Yes?
So what's an example of integrating this with Watson?
So the beauty of this is Watson has a huge presence, and it makes up a tremendous amount of our Bluemix and or our platform as a service. And so, like I mentioned before, using Bluemix allows you to take advantage of some of those Watson services. And so there's nothing stopping you from tonight going and downloading Edgent, putting it on an Android or a Pi device, going on, signing on, grabbing a Bluemix account, and putting some Watson services in place, registering this device, and you're off and running. Because that's all it takes, really. Yes?
But again, what services, give an example of relevant services with Watson.
Speech to text,
Just like that.
image processing, image classification. Plug a camera in your device, take a frame every so many seconds, and do image processing. Capture sound and do speech to text if you're capturing, English type verbal data. Yeah. Yes, sir.
I can foresee there being a problem with high channel data acquisition systems to basically interface with an Edgent platform. Is it offered as a microservice?
So what we've had is companies like Cisco and others have partnered with IBM, and there is a focus on the microservice to to extend the edge, to make the edge more robust, and not only that, but even higher level, maybe one step away from the edge type activity. What I would see is that Edgent would be a complement to that. I wouldn't see it as unless there's something that, for the example that you particularly mentioned, unless there's something incompatible with where we can't run, like it's a platform or something that doesn't have our requirements. Like I said, all we need is
Well, I'm
Java
thinking like
7 or 8.
an on-premise situation where the data doesn't leave the building, and so it has to process.
Okay,
all
so
systems.
in that perspective, where you
On-site.
have to process data, I can think of like a manufacturing case where you have OPC data coming off of an assembly line or some sort of manufacturing line.
That's a good
and
example.
you have a centralized Edgent device, right, that is for that particular line, that's taking in all the OPC data through, locally for that line, doing some level of analytics, and then aggregating and putting other, events of, deltas or whatever events of interest up to the deeper analytics system. That way it doesn't leave the premises and it goes to their own data center.
Thanks.
Yes, sir?
I know you have to go to the airport here soon. I was just wondering, can I get a copy of, or can you provide a copy of your presentation?
Absolutely,
Very interesting.
absolutely. Yes?
Is there a notion of like localized peer-to-peer edge communications at all?
I'm sure that that's an architecture that would gain or have some legs. I think it's not something that I've addressed with any of my clients. Really, when we put an Edgent or an edge device in place, like the manufacturing example that I just mentioned, usually Edgent would be like a single collection point, right, for a group of sensors or for an operation, and then that would be a single relay into the analytics system, not necessarily handing off to another Edgent device to do something else. I just haven't seen that, but nothing's stopping you from doing that. From an architectural perspective, I really haven't seen that used. But good question. Yes?
So I'm curious about like the API when you're constructing the stream processing DAG, like how you're building the different components on top of each other. Is that done like explicitly, like this join feeds into this transform, or is it declaratively? Like, is there some?
Well, you can identify the type of processing that you want to do based on the source type, based on any number of different triggers or conditions. So let's say you've got a dozen sensors coming in to a single Edgent device. Well, everything for the pressure sensor has some sort of flow to it, and everything for the temperature has some sort of shorter flow because we have to do less stuff to it. But as I mentioned before, you can union all that together, right, into a single record that has all of those readings and send that, or aggregates of that, up to your analytics system, your deeper analytics system. Did that answer your question?
So I think you answered it.
Okay.
Basically, explicitly, they should be.
Yeah, there's nothing specific that there's not a pattern or a requirement for you to do one thing or another. You're pretty free to do whatever suits your needs. But I was just giving, hopefully the examples I gave you an idea of kind of some of the things that you can do. Yes, sir.
What wrappers do you provide for the kernel?
I'm sorry, say it one more
What
time.
wrappers do you provide for the kernel? Can you interface Python with the Java core?
So that's a good question. I don't know the answer to that. I can take that and answer that afterwards. I've not been asked that. That's a good question. Yes, sir.
So just now you mentioned the hookup a camera. So does the data format have to be JSON, or can it be like binary?
It could be binary.
Could be, and does it support like a video streaming or?
So video streaming, I would think that the type of heavy lifting that would require might make you have a bigger machine because video processing is fairly CPU intensive. So I don't know that you would be doing that on this video on a Pi or something that small, but there's nothing stopping you in Edgent from doing that type of work as long as the machine can handle the throughput. Anybody else? Yes, sir.
Is it easy possible to change the kind of transformations that you're doing at runtime, like remotely? In other words, can I have my Edgent device be listening for updates to say I want to do this new transformation and have that emitted to this other source?
So that's a great question. So one of the things that we did was in our latest release of our streaming analytics is we allowed for visibility and communication down to an Edgent device. And so being able to dynamically, after something's underway, push down some of the changes, instantiate those changes, and essentially, start collecting the data with your new updates, that's possible. Yes, sir.
Is there any way to provision the devices somehow on a mass scale? Like I want to put out Agent on 10 million sensor devices or Raspberry Pis or whatever that is.
That's a good question. I don't, not that I'm aware of.
Actually, just using resin.
Yeah. Yeah, so from a resource perspective, I'm not sure what we've seen there because I really haven't had exposure to that, but I can get back to you with that answer. So wrapper and resin. Yes, sir.
So you mentioned that you can do windowing.
Yes.
Are there any limits to the size of the windows?
Sorry?
Are there any limits to the size of the windows?
It's just for the memory on the machine. So let me wrap up. We, this is essentially the architecture. And again, the control loop device commands, being able to come back through the edge device and do some sort of activity. This is how you get started with Edgent. Please jump in there, register, tell us what you think, tell us what you like. We'd really like to interact with it. I actually need to hand the mic over to Maureen. What we'll do is David will have my contact information. I'll also make sure that he has a copy of the presentation and he can distribute it to everybody. I encourage you, like I said, please reach out to me or Maureen if you have any questions or concerns, want to talk about something in more depth. And I will have the takeaway to get back to your question on wrapper, your question on resource provisioning, and then the general group's point on participating in a POC with this. One last question. Yes, sir.
Are there other corporations contributing to this at
Yes.
the degree that IBM is?
That's a good question. I'm not sure to what level. We do have other companies in production with Edgent. All right. Thank you guys so much for your time. I really appreciate it.